Okay, so class, good morning. Morning there online. Okay, Kolajan,
Sir,
are you joining?
yes, sir, because these things are obstructing my view.
Come closer here, it will be having echo. Yeah, come out of class.
I should come out. Yeah.
Otherwise, we'll be having echo.
Echo.
Yeah. Okay, so let's get started. I chose the topics will be not following like one by one. I'm first targeting those with calculations. And those similar to the topics in science. For example, we are starting with module 1. We are starting with the metal cutting because it is the same as the statics. Okay? It is the same as the statics. That is why I said those for science, make sure you join so that as we discuss, you'll find that the topics in science, you are able to do them. Okay? So I want us to make sure we pay very good attention here. Okay, so we are on metal cutting. When we are dealing with metal cutting, this is now the application. In science, you learn about statics, you learn about how the forces are acting and what are the reactions. Now in here, we look at the lathe machine and all the cutting processes which is supposed to be done in the theory. We'll find time to explain just the theory. But now the main focus is the calculations around the metal cutting. Okay? Now, on the metal cutting, when you come to science, it falls under the topic of what? Statics. Statics. Okay? At the statics, what we look at is the forces on a plane. Forces on a plane. So for example, this is the plane and I've got the support and another support. Then I've got a force acting. So this is the applied force, F. This is my reaction R1 and my reaction R2. Okay? Then I've got length L. And this one from there to there is L1. Doesn't matter what length it is, but it's L1. Then let me have this side as L2. Okay, so this is the simple drawing that we have. Okay, it's a simple drawing, and we call this is a simply supported beam. Simply supported beam. Now, when we are calculating the reaction, because that's what is critical here, we need to be able to calculate the reaction so that we know that if it's a cutting tool you are using, will it be able to withstand certain forces? Okay? Now, what we do here, for us to calculate the reactions, we are going to use moments. To calculate reaction, we use moments. When we talk of moments, moments means force times distance times perpendicular distance. So moment is force times perpendicular distance. That's what moment is. Okay? So when we look at this aspect, for us to calculate moments about R, I'll call it this side is A, this side is B. To calculate the reactions, we need to work with moments. So this is how we do. Okay? I hope you all remember how a seesaw works. Ne? When you go to the park, where you sit one side, one person sits on one side, the other person sits the other side, then you work with seesaw. Eh? You remember class there online? Huh? Do we remember seesaw? How the seesaw works? Anybody who doesn't remember anything? Okay. A seesaw is like this. You have got a support in the middle. One person sits there, another person sits there. This one will be going this way. The other one will be going that way. You balance the forces. So we are going to take the principle of a seesaw. Make sure all of you online, keep your mic on mute so that it doesn't make a cracking sound on my side. Yeah, when you ask a question, you raise your hand, I'll attend to you. So now, using the concept of seesaw, we are going to say, take moments about B. Take moments about B. Calculate R1. Take moments about B. Calculate R1. So this is how you go about it. Your drawing will be like this. B will become neutral. Then that force B becomes neutral. Then the force applied, the reaction R1. The distance from B there, it's L. Then this distance, L1. So, whenever you have a scenario like this, reduce it to a simplified aspect. So, I've reduced it to this one. Because I'm solving R1, therefore, I've made RB a neutral point. Neutral point, it means this is the turning what? Point. Or you call it pivot. That's where it is supported. Then you have the rotation taking place. Now, when solving the force, you say R1 times L. R1 times the distance from B. R1 times the distance from B is equal to F times distance L1. R1 times distance from B, F times distance L1. It is where the force is applied from the turning point. Where the force is applied from the turning point. Is that clear? Any questions?
Sir,
Yes.
the reaction 1, we multiplied with the original length.
Reaction 1 with the length from where it is acting. From the pivot to where it is acting. Yes.
And then F we multiply the middle of the length.
Yes. Not only the middle, from where F is acting to the pivot. Yes. So here, your R1 is equal to F L1 divided by L. It means you don't need to master the equations. You just need to know the drawing. How do I get the equation? Put numbers, punch. Okay? So, any questions so far? Okay.